In today's video, we're going to discuss section 13, which is the intro to stats. So I put the notes over here on the side for us for reference. Then I'll switch this board over so you don't have to look at my face. To a nice whiteboard I can use. So intro to stats has three important measures of central tendency that we want to talk about first. The first of those is the mean. Mean is also known as the average. And really what we do in order to find the average is we add all the values up at the top and we divide by the number of items. So if we want to find the average, it's a fraction where the top is the sum of observations over the total number of observations. It's not the only way to find the middle, though. Sometimes the mean can give us an average that isn't necessarily indicative of the center because maybe one number is way bigger or way smaller than the rest of the numbers. And what that does is it kind of pulls the average in one direction. So sometimes the mean isn't the best way to find out what the middle is. Another way that we can find the middle is what's known as the median. The median is the middle observation One important note to keep in mind about the median, though, is it's the middle observation when data is arranged from greatest to smallest or vice versa. I'm going to just put from smallest to largest. That's usually what we use. There's a third measure of central tendency that we use. We refer to all of these as the three M's: the mean, which is the average, the median, which is the middle observation, and then lastly, the mode. The mode necessarily isn't the middle. It's not a really good measure of the middle. It's a measure of like who's most popular. So the definition of the mode is the observation that appears most frequently. So we'll do an example here, particularly looking at the difference between mean and median. So in this example, we have a room and the following people are there with these ages: 2, 3, 4, 5, geez, this sounds like my house during quarantine, 5, 7, and 64. I have a lot of kids here. Not that many kids, but I got a lot of kids here. And we want to find out what's the average age of these kids. You might even be able to come up with a scenario where this is happening. I don't know, maybe this is a caretaker and they're looking after, I don't know, a bunch of preschool and early elementary age kids. I don't know, I'm just guessing here. But you can see the problem with looking at the average right here. That if we remove this 64-year-old person, the average is going to be much more indicative of children between the ages of 2 and 7. But once we throw this 64-year-old person in here, it throws everything off. Let's calculate the mean. The mean is 2 plus 3 plus 4 plus 5 plus 5 plus 7 plus 64. So we add all the observations in the numerator. The denominator is the number of observations. So how many people are in this room? 1, 2, 3, 4, 5, 6, 7 people total in this room. Adding this up, we get 90 divided by 7, which doesn't go out very nicely, but we'll round to one decimal place. And we'll say it's about 12.9. So when we look at this number as a measure of the middle of this group, it's telling us that the average age is almost 13 years old. But we know of these 7 people that are in the room, 6 of them aren't even are closely to half that age, right? None of them are even teenagers. They're all pretty young. So you can see what that 64 does. We have a name for that 64, by the way. You're going to go into a bunch more detail in 120. But for now, let's just refer to it as an outlier. An outlier is any term or any set of data that appears unusual in the set because it's unusually large or it's unusually small. And it has a massive effect on the way we analyze that data, right? If someone just said, hey, what's the average age of the kids in that room? And you told them 13, that's not a very good indicator of the kids in that room. No one's really near the age 13. They're all much younger than that. And 13 isn't a good indicator for the 64-year-old either. So instead of looking at the mean, let's try a different measure. Let's look at the median. So for the median, I'm going to write out all of these ages again. If there's something that happens more than once, I'm going to put it in there as well. If these numbers were not written in order, I would put them in order. Then we arrange them and we cover up. Cover up the 64 and the 2. I cover up the 3 and the 7. And then I cover up this 5 and this 4. And we can see the middle observation here is this 5 right here. We had 3 data points to the left and 3 data points to the right. I like the cover-up method the best. So the median here is 5. You didn't think you were going to get serenaded in this video, but you did.
Sweet girl.
So a big question that we have with median is, what happens if you don't have an odd number of observations? So keep in mind, for even observations, so even numbers of observations, we take the average of the two middle. So I'm going to actually do one more example of this before we jump into anything else, just so that we get an idea of what's happening. Suppose I wanted to take the median of the following numbers: 4, 6, 8, 10. Notice that I'll put some more here actually. Let's put 11 and 12 over here also. So here I have a set of numbers, 6 numbers in total, and I want to know what is the median. So because I don't have a true middle here, what I do is I look at the two that are closest to the middle and I take the average of those values. Again, the cover-up method can be helpful, so I'll use my thumbs, or my hands. I'll cover up 4 and 12. I'll cover up 6 and 11, and we can see that I have two numbers in the middle. If I try to cover those up, I have no median. So I'm left with these two values right here, and I take the average of those two. So to calculate the average, I do 8 plus 10 divided by 2, which is 18 over 2, or 9. So it turns out, which makes sense, the middle number in between these two is 9, and that is our median. Let's get rid of this mean stuff too. So median can be calculated one of two ways. It's really important for us to know whether we have an odd number. If we have an odd number of data points, then the median is a unique value that exists in the set. And if we have an even number of data points, then we're going to take the average of the middle two values and create a new number that's not part of our set that will represent the median. We talked about the idea of outliers being really big or really small numbers, and they stand out from the others. In 120, in the next math class, you'll talk more about what it means to be an outlier, or if I have a set of data, how I can calculate that outlier. But for now, we should learn some of the tools that we're going to need to develop that. So that's where we go and we discuss the idea of range. Range is pretty straightforward. It's the largest value minus the smallest value. So what we do is we subtract the largest data point minus the smallest data point, and it just allows us to get an idea of how far apart our numbers are or what kind of range we're looking at. It becomes really important when we want visual representations of data to know what the range is. So that way we make sure that our scale looks proper and that we can fit all of the important data on one image. We have one last concept to talk about in Intro to Stats, and it's the idea of the 5-number summary. The 5-number summary. The 5-number summary has 5 important numbers in order for us to make a good indication of the amount of data and its spread. Those 5 numbers are the minimum, which I'll just refer to as min, a new value we're going to talk about soon called Q1 or quartile 1. We have the median, which we already discussed. We have another quartile, which we're going to refer to as Q3. By the way, the median can also be thought of as Q2. And then lastly, on the very far end, we would have the maximum, or what I'm just going to refer to as the max. Now we've discussed how to calculate the median already. The minimum is simply just the smallest value in the whole data set, and the maximum is the largest value in the data set. So it's really important that we order these numbers first. We want to put them in order, just like we were calculating the median. Then we have to talk about what is Q1 and what is Q3. Remember that the median is that middle value. And when we calculate that median, what it does is it splits our data up into 2 halves, a lower half and an upper half. Quartile 1 is the median of the lower half. And Q3 is the median of the upper half. So we'll do an example of this. Do I have a good 5-number summary one? I do. Let's calculate one. I'm going to write out a set. Let's use the second set. 5, 12, 14, 21, 22, 27, 29, 33, 36, 37, 40, and 54. Almost ran out of room there. Now we want to find the middle observation, we want to find the minimum, we want to find the max. I'm going to write out all of those important numbers that we talked about in the 5-number summary, and we can fill them in as we go. The min and the max, pretty straightforward. Our minimum value is 5, our maximum value is 54. Now we'll use our cover-up method to find the median. We cover up the 5 and the 54, the 12 and the 40, the 14 and the 37, the 21 and the 36, the 22 and the 33, and we notice that we have 2 numbers in the middle, 27 and 29, and we have to take the average of those 2 to find the true median. Now, what is halfway between 27 and 29? Well, 28. And again, if we add up 27 plus 29 and divide by 2, it will give us this value. So 28 is our true median. Let's throw median again. And now we talk about finding these quartiles. So what I like to do is I like to underline the first half of the data, and I'm going to underline the second half of the data. Notice that in this first half, I have 6 observations, and in the second half, I have 6 observations. Because these numbers are not odd, or the set is not odd, there's no unique middle here. There's no number that I'm going to be able to choose and just look at. Also notice I did not include this number that wasn't in the data when I'm calculating these quartiles. So once you find the median, don't include it in your first half, don't include it in your second half. So at this point here, we can see using the cover-up method that there should be a number we're interested in between this 14 and 21 that's going to represent the first quartile. To find that number, we add 14 plus 21 and we divide by 2. 14 plus 21 divided by 2 is 17.5. This is our first quartile. We do this third quartile in the same way. We have six numbers of data here. There's no true middle. Again, using that cover-up method would put us right in between the 36 and the 37. Halfway between 36 and 37 is 36 and a half, 36.5. And so that is going to play the role of the third quartile, or Q3. And now we've written out all 5 of those numbers for the 5-number summary. That's it for Intro to Stats today. Feel free to send me an email or let me know if you have more questions about the 5-number summary in particular. I'd be glad to go over some more examples. We're not going to do anything visual with it, like drawing box and whisker plots, which is a really important connection from the stuff that we just talked about, but it's good to know it. So if you have some free time and you want to look up something that's relevant to this, I would recommend box and whisker plot. It will be something that we cover in Math 120 though. Hope you have a great day.